Hi everyone, this is lesson 6.2 on similarity transformations. So today we are going to learn how to perform a dilation to find similar figures. That's what a similarity transformation is, because for a dilation, the side lengths are not preserved, so you would create proportional sides, but the angles are, so then you would create two similar figures. So an overview of dilations is a dilation is a non-rigid motion. Remember, rigid means that the sides would stay the same. But here, if it's a dilation, then the sides are not going to be staying the same. Smart Slate is still waking up, so we'll give it a minute. So that's really important here. Dilation is a non-rigid motion, where translation, reflection, rotation, those are rigid motions. So because it enlarges or reduces the figure, resulting in figures that are similar, but not congruent, unless the scale factor is 1. If the scale factor is 1, then it would be congruent. The preimage is enlarged or reduced by a scale factor k around a point called the center of rotation. For us, the center of rotation is just going to be the origin 0, 0. That'll make things easier for us. So here, if the scale factor is less than 1, so if it's between, scale factor can't be negative, but if it's between 0 and 1, so fraction or decimal between 0 and 1, then it is a reduction. It gets smaller. So here you've got triangle ABC and triangle A prime B prime C prime is the dilation. So your scale factor here is 1/2. And this is the center of dilation. So each point got half as small. Okay, so here A prime B prime would be 1/2 of side AB. So if you find side AB is 2, so A prime B prime is just 1. And here an enlargement is if K is greater than 1. And really there's no limit to what K can be. It can be as big as 100 or more. So here, if K is 2, then it's the opposite. K gets twice as big. So if side AB is 2, then side A prime B prime is 4. So it gets twice as big. And here it shows that the center of dilation at the origin. So each point, so the distance between the vertex and the center of dilation gets twice as large. So here, this would be, well, the origin to B prime would be twice as large as the origin to B. All right, pretty simple. So for a couple dilation properties, so with a line segment, the center of dilation not on the line segment. So if you've got a segment here, and this is kind of what you were learning yesterday in the exploration, but if you've got a segment AC, here's the center of dilation, then each point gets twice as far away. Well, what's the scale factor? Let's say the scale factor is 2 in this case. So gets twice as far away. So A prime would be up here. Okay, so over here, you could draw a line through the center of dilation, your point, and the image point, and the pre-image point. So you should be able to draw a line through all of those. Okay, so that's one way you can figure out where it would be if the center of dilation is not the origin and not on the line segment. So here, your center of dilation is the line segment. So you've got AC, and then here's the center of dilation. So if the center of dilation is on the line segment, then you just get the same line segment, but it's just twice as big. If it's an actual line, then it's the same line because the line goes on for infinity. Okay, so the center of dilation is not on the line segment being dilated. The resulting dilated line AC is, I'm going to try to see if all right, finally got my Smart Slate to wake up, maybe. So is parallel to AC. So these two are parallel. They have the same slope. Both have a slope of -1/2. And then the center of dilation is on the line segment being dilated. The resulting dilated line, AC, A prime, C prime, is the same as AC, just enlarged or reduced. It can also be said that A prime C prime in this case would be twice AC. I think that's what they wanted us to say, or the same thing as, or the same line. So if you made an equation for both of these line segments, they would be the same. Anyways, so here's an example. So you've got this triangle here. Graph the dilated image of triangle JKL using a scale factor of 2. So the easiest way to do this is to write out all the points for this triangle, and then we're just going to, if the center is the origin, we are just going to multiply each of the coordinates by 2. So let's get to it. So J is 2, 4. So J prime is going to be 4, 8. So 4, 1, 2, 3, 4, 5, 6, 7, 8. Right? And then K is 1, 1. So K prime would be 2, 2. L is 4, 0. So L prime is going to be 8, 0. And then you would draw your triangle. All right, so really it doesn't get too much harder than that. Okay, that's what you need to know. But we'll do a few more examples anyways. So graph the dilated image of quadrilateral MNOP using a scale factor of 1/3 and the origin as the center of dilation. So we get all the coordinates and multiply them all by 1/3. So here this goes up, I think this goes up to 9. So this would be 3, 9. Oops. 3, 9, N is 6, 0, O is 3, most likely 6, and then P is negative 3, 0. So multiply everything by 1/3. 1, 3, 2, 0, 1, 2, negative 1, 0, and graph the image. Graph and label. I'm sorry, this should be negative 6, right? So this would be negative 2. So 1, negative 2 is O prime, negative 1, 0 is P prime. All right, so that one's finished. Describe the dilation of quadrilateral MNOP using the origin as a scale factor. So one thing you can do here, you can figure out any of the points, or if there's a side length that's easy to figure out that is horizontal or vertical, you can count the sides. If not, then you would have to use the distance formula, but it would be easier to use the points. So I'll show it both ways. So here, if M is 3, 3 and M prime is 1, 1, then your scale factor is going to be 1/3 because you'd have to multiply 3 by 1/3 to get 1. Or you could count PO, which would be what this goes from negative 9 to 6, so 15. And then P prime O prime is 5, so that's 1/3 again. So to describe the dilation, dilation is a reduction with a scale factor of 1/3. Okay, so also important is that when you find a scale factor of a dilation, the way to do it is you take the you take the new image and you divide it by the pre-image. So here we took 5 and divided it by 15. Or you would take 3 and divide it by, you take 1 and divide it by 3. All right, so that's how you figure out the scale factor of a dilation. All right, and then a couple other things about perimeter and area real quick. The dilation of a rectangle has a scale factor of 4 to 1. And So then the effect of the dilation of the perimeter would be the same. So it's going to be just 4 times bigger. However, the effect of the dilation of the area is going to be whatever that the scale factor is squared. So if the scale factor is 4, then it's going to be 16 times bigger. All right, so that is all for this lesson. I hope you guys have a great day.